We are with Unit 4, Lesson 14, Homework Help. Again, my screen looks a little different than yours. Problems are the exact same. Today, what we really focused on was substitution and recognizing that when we have one variable completely isolated all alone by itself, we can substitute that variable directly into its partner equation. So as a system of equations, these two are partners. That means that their x-coordinate and their y-coordinate have to be equal at the same time in order to be one solution. And of course, there's no solution in infinite solutions. When we look at these two, what we're directly looking at is we're looking at the system or the situation where we see two equations that we could just subtract this 4x from right here and right here. And we see this equation as y is equal to negative 4 times x plus 7. And we can quickly see that the two slopes are different, which guarantees that I have one solution. Another option, alternatively, is we can just simply use substitution from the beginning to be able to solve, where we can say that since y is equal to 6 times x, I can just simply put that 6 times x right here in front of the y and say that 4 times x plus 6 times x is equal to 7. Or that I can get 10 times x is equal to 7. Division property of equality would tell me x is equal to 7/10, or we can write that as 7/10. I'm not going to care which one it is that you want to use here, but decimals might be a little bit easier to work this one out. Now, to figure out what y is, I need to use substitution. So rather than having 6x, I want to have now y is equal to 6 times 7/10. And then in the other equation, I have 4 times 7/10 plus y is equal to 7. Now, in our situations that we're after right here, let's go ahead and we'll use a calculator to figure out what these are. Move this to the other side. So we have 6 times 7/10 is going to be 4 2/10. So when we solve for other one, we want to make sure that we get 4 2/10. Y is equal to 4 2/10. What I can do is I can substitute that value of 4 2/10 into this other equation. And if it comes out true when x is 7/10 and y is 4 2/10, if that equals 7, then I know for sure that I have the right solution. So here we go. 4 times 7/10 equals 2 8/10 plus 4 2/10. It equals 7. So guess what? On my equation, when I have these two values over here, when I have x equals to 7/10 and y equals 4 2/10, I know that these two equations right here come out exactly true, exactly the same, because they both come out to when x is 7/10, y is 4 2/10. They give us the exact same values and they make it true. So in here, type your answer below. We want to have 7/10 and we want to have 4 2/10. Not a very amazing x and y intercept, but it's still true nonetheless for both of those. We would go through and we would perform the exact same process on the next one. May not be exactly the prettiest or the most favorite outcome, but we still know this. Here we have y is equal to 3 times x. But take a look at what we have. We also have x is equal to a negative 2 times y plus 70. So just because I want to do this a little bit different, I have two options. I can go like this. I can say y is equal to 3 times negative 2 times y plus 70. And check that out. There's no more x to solve for. Now let's say you're like, Mr. Coulter, you're crazy. I want to go the other route. Okay, cool. Then go the other route and take this value right here, the 3 times x, and plug it in for y. And say, I want to solve x is equal to negative 2 times 3 times x plus 70. And you know the coolest part about this is now I can solve for x and y, and then I just need to verify if I'm really right. So this first one, let's do that. Y is equal to negative 6 times, or y is equal to negative 6 times y plus 210. I want to add my 6 times y to both sides to give me 7 times y is equal to 210. And so y must be equal to 30. Pretty cool. Now let's solve over here. X is equal to a negative 6x plus 70 add my 6 times x, and my 6 times x. I get 7 times x is equal to 70, and I find out that x is going to be equal to 10. Now, this is a really good piece because now what I can do is I say, I think I have x and y for both of them. So what I'm going to do is just simply come back here and I'm going to substitute both of these equations and see if for sure when y is equal to 30, does that equal 3 times 10? Well, I know it does in the first one because I know 3 times 10 is 30. So this one, check. That's the right ordered pair. I think that my ordered pair is 10. I'll put it right here, 10 and 30. I think that's what it is. I hope that's what it is. On my next one, I want to put 10 is equal to negative 2 times 30 plus 70, which simplifies to negative 60 plus plus 70. And the math doesn't lie, folks. We have the right solution because when I substitute this into both expressions come out true. Both equations come out true. I'm a happy guy because I have both of my equations. So pay close attention to both of those as you're doing this. It's all about substitution and then solving to make sure you get the right values, to substitute back in again just to make sure you get the right values. So with that in mind, keep that in mind, and let's think about this, the substitution piece again. Which equation together with negative 1 5/10 times x plus 3 makes a system with one solution? Think about the piece to this. One solution, different slopes. Okay, different slopes. Well, right now, I know that this equation has a slope of negative 1 5/10. So now as I look at all of the rest of these, one solution has to have a different slope. So if I'm going to take a look and substitute these, I can obviously see A has the same slope, B has the same slope, and the rest of them I'm not really sure. E does not have the same slope, so it could very easily be E. Let's look at C and let's look at D just to make sure. I want a slope of negative 1 5/10. So letter C, I see 2 times y is equal to negative 3 times x plus 6. All I really need to do is find the slope. So divide each of these by 2, and that gets me to slope-intercept form. Y equals negative 3 halves of x plus 3. I know that negative 3 halves is the same as negative 1 1/2, negative 1 5/10. C is gone. Oh man, who am I kidding? This is a multiple choice question. E is the only proper answer because the slope is different. This next one, 2 times y plus 3 times x equals 6. Watch this. All I simply do is subtract 3x from both sides, and I'm right back to what I just worked with. I'm right back to this over here. Letter C and letter D, that's really the exact same equation, and guess what? It's the exact same as A. A, C, D, they are all the same equations, so they can't work. B is just another parallel equation to it. But the fact that this one has a different slope, the slope right here is m equals negative 2, tells me all I need to know, different slopes, one solution. I got way too excited about that one. The next one, part A, this system is said to have no solution. Change one constant or coefficient to make a new system with one solution. Okay, again, one solution. We have to have different slopes. So let's think about this. Why did they say that these two have no solution? Meaning that they are not going to intersect. When I see the equation x minus 6 times y is equal to 4, and I compare that equation to 3 times x minus 18 times y is equal to 4, how can they say that these two have no solution? How can they tell me that they're parallel when they look completely different? The first thing I want to do is I want to think about simplifying or reducing some values, right? Over here on the right side, 3x minus 18 times y equals 4. I see that if I divide this one by 3, the y term by 3, and the c term by 3, I get a little bit of different things. I get 3 divided by 3 is 1 times x, 18 divided by 3 is 6 times y is equal to 4/3. And now I can see that my two equations actually simplify to having the exact same beginning terms, which means as it sits right now, this first part of the equation right here has a different outcome. 4 is not equal to 4/3. While that is not the slope, it doesn't characterize or demonstrate the slope at all, it does give us an idea that my first two terms, a times x, so my first coefficient a and my coefficient b, when I see this, a times x plus b times y is equal to a times x plus b times y, this is a dead giveaway to all solutions or no solutions. The difference comes in the constant value. Again, variable terms are exactly the same, but the constant value is different. When the variable terms are exactly the same and yet the constant values are different, we have no solution. So how can I change this to make it work so that I get exactly one solution? Well, all I have to do is mess with my variable terms. Done. Now all of a sudden I have a completely different equation with a completely different slope. I could have put a 3 right here, and that could have changed it as well. Changing a constant, however, wouldn't have done a single bit of difference if I hadn't have changed the coefficient of x. Okay? I need to have one solution. If I would have changed one of these constants and maybe said like, oh look, hey, 4/3, now all of a sudden I have infinite solutions because I have two of the exact same equations. Maybe I change 4/3 to 34. It's still no solution because the thing that matters are the variable terms. They have to be different in order to be one solution. Okay? When we talk about infinite solutions, I guess I kind of gave that away. We would just have to change the coefficient, or excuse me, the constant term to make sure that it's exactly the same so that we see the exact same equations. Okay? All right, next one. Match each graph to the equation. I'm going to tell you right now that when you're going to match the graph to the equation, what you have to look for is two things: the slope and the y-intercept. This is review. So when we're looking for these, number one, look for the slope. Number two, look for the b term, which is the y-coordinate of the y-intercept. I'll do one of these, you do the rest of them. Find some nice integer points and use some rise over run. I see a rise of 2, a run of 1. That tells me my slope is 2/1 or simply 2. That eliminates this one and this one because this is not a negative slope. So now the question is, do I pass through +3 or -3 on the y-axis? I see my y-intercept is 0, 3. My b term is the y-coordinate, so that's 3. That means that the very first one is my answer. Do the same thing for part B. Find the slope, find the y-intercept. Part C, the slope and the y-intercept. I can't believe that red circle or red oval came back. Part D, slope and y-intercept. And then the final one, talking about slope. What is the slope of the line between these 2 points? Well, think about slope formula. Slope is equal to y2 minus y sub 1 divided by x sub 2 minus x sub 1. What does this formula mean? This formula means that you're finding the change in y over the change in x. There are several ways to do this, but under this formula, how do I know which one is x1 and how do I know which one is y1? It all comes down to the x coordinates. x1 is the coordinate that is the lowest value, because when we read a graph from left to right, such as this one, -3 and +4, I'm going to come down just a little bit and go ahead and use this graph up above. When we talk about the ordered pair, -3, +4, we're talking about a slope from here over here to 1, 7. That's somewhere up here, right? So we can tell it's a positive slope, but it's off the graph. What we're looking for here is we're saying, what's my rise to my run as a ratio? The x coordinate that comes first as x sub 1 is the first coordinate pair or first point that we see working our way from left to right. This one right here would thus become x sub 1 and y sub 1. This other one over here that's really hard to see, blue on blue, would give us the other ordered pair of x sub 2 and y sub 2. And that's how we know which one it is. Obviously, x sub 1 is the smaller of the two. So when we come down here and look at these, we could see that this would be ordered pair, ordered pair number 1, and this would be ordered pair number 2. And then we could set this up and say ordered pair number 2, y term is 7 minus 4. And then we want to follow the same order with the x values and go 1 minus negative 3. Simplify that and you'll find what the slope is, guaranteed. You're doing great. Give me a shout out when you need some more help, and have a great time with your homework.